Hello everyone, my name is Rob Proulx, Agriculture Technology Systems Specialist with NDSU Extension, and I'm going to share some information with you on monitoring and managing delta T. So in this presentation, there's four main points I'd like to get across. First is, what is delta T? Then why does it matter? How can you monitor and manage delta T? And finally, what's the North Dakota context for delta T? So first up, what is delta T? And one of the best ways to describe this is to demonstrate how a sling psychrometer works, and I have a short video clip here that will do that.
In case you missed it, we're going to go over how to use a sling psychrometer. Sling psychrometers can come in lots of different shapes and sizes. They can be cheap like the ones that we have here, or they can be nice hard plastic with built-in thermometers. To begin with, you take the wet bulb thermometer and dip it in water. You spin the sling psychrometer around. While you're doing that, the water is evaporating off of the wet bulb. You then read the thermometers. The dry bulb, in this case, read 24 degrees Celsius, while the wet bulb read 21.
So the reason why there's a difference between the dry and the wet bulb is that evaporation is a cooling process. So as water is evaporating off of that wet cotton sock at the end of the wet bulb, it's cooling the bulb, driving the temperature down. It really is the same phenomenon if you step out of a body of water, like a shower, a lake, a pool, whatever it might be, and you'll start to feel cooler because as the water is evaporating off of you, it's a cooling process. So the difference between those two bulbs, the dry bulb and the wet bulb, is the delta T. So in this example, 3 degrees Fahrenheit. You might also hear this described as wet bulb depression, or think of it simply as the evaporative ability of the air. The more ability the air has to evaporate moisture, the more that wet bulb temperature is going to drop. So the bigger the difference between these two, the more evaporative ability that the air has. So the bigger the delta T, the more evaporative ability of the air. So this example, again, is a delta T of 3 degrees Fahrenheit. It's actually a relatively low evaporative capacity of the air. If the difference were, say, 9 degrees Fahrenheit, that would represent a greater evaporative ability of the air. So the bigger the delta T, the more evaporation that can occur. So why does this matter for pesticide spraying? To get to that question, it helps to understand a little bit about how pesticides get from the spray tank to the target to have biological activity. So first, that liquid needs to be atomized into droplets, and those droplets need to transport to the target. Then those droplets need to impact the target, be retained on the target, and form a deposit on the target. And then finally, those droplets will have a biological effect on the target. And here I'm going to focus on herbicide use, so it's going to be a biological effect on the target plant. So there are things that can happen along the way that can interrupt this process. And one area that delta T impacts is right at the beginning in the atomization of droplets and their transport to the target. So if we look at this a little bit closer at what can happen between a droplet being atomized and impacting the target, evaporation plays a role. So under high delta T conditions, high evaporation, what's going to happen is that those droplets are going to be getting smaller and you're going to be losing volume, which is going to make those droplets more drift prone. And when they drift, you're going to lose most of those droplets. It's possible that a small portion of them will be redistributed and still impact the target, but you're going to lose most of those droplets to drift. But that's not the complete story, because delta T also impacts this transfer of pesticides later on in the process. So delta T also impacts the time between when that deposit forms on the leaf and the herbicide has enough time to cause a biological effect in the plant. So evaporation is one of the micrometeorological conditions that affects this. And under high delta T, you're more likely to have what this diagram describes as volatilization. But it isn't so much volatilization of the active ingredient, it's actually volatilization of the water that's mixed with the herbicide. So under high delta T conditions, what can happen, you have high evaporation, you can lose that water out of that deposit on the plant. And you could desiccate that deposit before the herbicide has a chance to move into the plant. If it's an oil-based herbicide, it might still be effective and transfer into the plant. If it's a solution, what you might end up with is a dry active ingredient that's stranded on the surface of the leaf. So something like Liberty, for example, you're going to lose effectiveness if those droplets desiccate before the active ingredient can move into the leaf. Under low delta T conditions, you can have the opposite occur. So rather than those deposits desiccating off of the leaf surface, they will actually persist for a longer period of time because you have low evaporation and those deposits will be maintained on the leaf surface for longer. So under low delta T conditions, the concern is that any driftable droplets you have will be more potent because they'll persist longer in the environment and have a greater opportunity to move into the plant. So that's why delta T matters. So next is how can you monitor delta T and then manage it? So we'll start first with monitoring it, and you have several options here. One is that a spray rig might actually be capable of monitoring this. So this is a screen from a John Deere sprayer. It's an optional add-on to have a weather station right on the sprayer, and then the display screen in the cab will show delta T. And other manufacturers might have this capability as well. There's handheld units you can use. So here's a couple examples of handheld weather instruments that NDSU Extension has and could demonstrate upon request. And of course we have NDON, which is a fantastic resource in North Dakota and parts of Minnesota. So here's a map from the new NDON site showing delta T. And this information is also available on the old NDON site here being shown in a table. And this information is also shown in the NDON inversion app, which the main function of the app is really to give inversion alerts, but there's a whole host of other relevant spray weather that's displayed in the app as well, and delta T is one of those variables. So how do you manage it? Well, the NDON inversion app provides some clues. So this is the color scale that's used to show delta T values in the app. So you have a fairly wide ideal range in the middle, and then caution if it's lower than ideal or above ideal. And then finally, at 19 and above, it's not recommended to spray under such high delta T conditions due to the amount of evaporation that will occur. Just to make you aware, these numbers are a little bit different, or these guidelines are a little bit different than what's shown in the North Dakota Weed Guide. It's the same ideal range, it's the same marginal conditions just above and just below the ideal range. But in the NDON inversion app, where it shows it unsuitable at 19 and above, it's actually from 18 to about 21.6 if it's a fine spray. So if it's a medium spray quality or a fine spray quality, fairly small droplets, it's unsuitable for spraying. But if you have a coarse, very coarse, ultra coarse, extremely coarse spray quality where you're spraying larger droplets, it's actually marginal conditions from 18 to 21.6. And then at values above that, it's unsuitable for spraying. Delta T is unsuitable for spraying no matter what droplet size you're using. I can only cover this in a shallow amount of depth. To learn more about this, search online for the NDSU Delta T supplement. Another great resource is sprayers101.com/delta T. The Sprayers 101 website is a fantastic resource on a whole host of different topics, and delta T being one of those topics. But summarizing those resources, how do you manage delta T? If you're in the marginal low delta T values, so 0 to 3, just realize that any driftable fines you have will persist longer and are more potent due to more effective uptake. So you might have more risk of crop injury when you have those low delta T's, and any drift you have might have greater potential for drift injury. So what do you do about it? I would not suggest postponing spraying. I think these are conditions that can be managed. Just adjust accordingly. Use your standard drift management techniques. If you have a really hot product mix, something that has a great potential to cause crop injury, maybe postpone applying that until your delta T values come up a little bit. If you have marginal high delta T values, then your counteraction for this is bigger droplets and more water. That's going to be your best approach if you have marginal high delta T to counteract the effect of the increased evaporation. And if you get into the unsuitable range, then ideally you should suspend your operations until the conditions improve, because you're just going to lose so much effectiveness of the spray due to the high evaporation. One thing to be aware of, though, is where these cutoffs came from. So the cutoffs that are in the North Dakota Weed Guide in the NDON inversion app, they originated in Australia in the 1990s, during a time when flat fan nozzles were the dominant technology. And there was a lot of concern over rapid evaporation of the fine droplets that make up a pretty good portion of those flat fan sprays. But as you might know, that's not the dominant technology anymore. Air induction nozzles and pre-orifice nozzles are the standard technology now. And these nozzles produce coarser sprays, and the larger droplets of those coarser sprays tend to resist fast evaporation. So these cutoffs, I wouldn't say we can definitively affirm them with these newer nozzle technologies. So there might be a little bit of wiggle room on what the exact cutoffs are. But nonetheless, I would recommend using those values as guidelines, really paying attention to your delta T's, and then paying attention to the outcomes that you get. And you really have the potential to learn a lot about how delta T is affecting your pesticide applications. So that's how you can monitor and manage delta T. Finally, what's the North Dakota context? So what do these values look like in North Dakota? So to get at this question, I performed a data analysis looking at data from NDON from 2020 to 2022. And I analyzed 8 locations of data, 4 that I categorized as being in the west, Williston, Minot, Dickinson, and Hettinger, and 4 in the east, Langdon, Carrington, Prosper, and Streeter. So I looked at June and July data only, since these are the months where most of the post-emergent spraying is going to be going on. I was interested in the relationship between wind and delta T, and all of these analyses assume that conditions are otherwise generally suitable for spraying. So there's no temperature inversion, it's during the daytime hours, so between sunrise and sunset, and it's not raining. In the diagrams that follow, if they're showing a color scheme for wind, 0 to 10 was considered optimal, and if the wind is gusting from 10 to 15 miles an hour, that was considered marginal high wind conditions. For delta T, optimal is in the darker shade of green, marginal low conditions in the lighter shade of green, marginal high conditions in 2 different shades of pink, whether it's the 14.4 to 18 or 18 to 21.6, and finally unsuitable conditions in the darker shade of pink. So the first diagram here shows delta T conditions during the day for the 3 years at these different locations. So in this diagram, the color is not reflecting the wind at all. Just know that the wind conditions could be anywhere gusting from 0 to 15 miles per hour. The colors represent the different delta T values according to the scale shared on the previous slide. The vertical component is time of day, so between sunrise and sunset. And the other part of the vertical component are the 3 different years. So 2020 is the top tier, 2021 the middle tier, 2022 the bottom tier. And then left to right, we're looking at the different locations in both June and July. So far left is Williston, then Dickinson, then Hettinger, and so on. And finally, you'll notice a lot of white space in this figure. Those gaps represent weather conditions that were otherwise unsuitable for spraying. So it was either raining, or a temperature inversion was present, or the winds were gusting over 15 miles per hour. So some of the lessons learned from this analysis. One is that in the morning, you really need to be looking for marginal low delta T conditions. We don't see much high delta T conditions in the morning. So here we're looking at from sunrise to 9 a.m. and we really don't see any pink anywhere at all. So the conditions, delta T conditions, were either marginal low or in the optimum range. So if you're going to be managing delta T in the morning, you just need to be thinking about what to do if the delta T's are a little bit lower than what would be ideal. If we extend this out to noon, we start to see a little bit more marginal high conditions, especially in 2021, but still, for the most part, not a lot of high delta T conditions in the morning. Another lesson learned is that 2021 was a highly challenging year for delta T. We had a lot of marginal high to excessively high delta T's in 2021. So you can see a lot of pink in 2021, a lot of dark pink, which would be unsuitable conditions due to high delta T, much more than when we compare it to 2020 and to 2022. There's still high delta T conditions in those 2 years as well, just not as much as what was seen in 2021. So if you are an applicator and if you can remember back to 2021, you might have noticed difficulties in getting good efficacy, good effectiveness when spraying, especially contact products, maybe Liberty, maybe bromoxynil, maybe some of the Site 14 or Group 14 products. If you had troubles in 2021 with some of those, it probably was not your imagination. It was really a challenging year for Delta T. And another lesson learned is that the western part of the state tends to have more of these challenging Delta T conditions than the eastern part of the state has. So here we're showing just those western locations in each year. You can see a fair amount of pink that is indicating those marginal high to excessively high Delta T conditions. If we box that off and then compare it to the right, the eastern locations, in the east we don't see as much of the pink. So we don't see as much of those high Delta T conditions. Another set of diagrams looks at this in a little bit different way and highlights the tallies of the different conditions that were encountered in these 3 years. So first, the most prevalent conditions you're going to encounter are to have winds that are marginally high and Delta T in the ideal range. So to lay out these diagrams for you, here we have the 3-year average, so from 2020 to 2022, the average across the 4 western locations on the left, average across the 4 eastern locations on the right, and the vertical component is the average number of days at a certain location. Hours might make a little bit more, it might make a little bit more sense to think of this in terms of hours, but I found that it was difficult to kind of wrap your head around hours, so I simply converted those hours value into days, but understand, of course, that there's a lot of gaps. You don't have consecutive days with conditions. There's variability. It's just a little bit easier number to wrap your head around. So in the West, average across those 3 years, about 15.9 days where the wind was gusting from 10 to 15 miles per hour, 65% of the time in June and July, and 13 days with Delta T in the optimum range about 53% of the time in June and July. But if we connect those two, we can now know how often we had those conditions together, and it equated to 7.8 of days within the sprayable hours of June and July, or 32% of the time. In the East, very similar, 7.7 days. So again, that was the most common condition you're going to encounter as an applicator, is to have marginally high wind with optimum Delta T. One of the next most prevalent conditions is highly challenging conditions, where you have not only marginally high wind, but also marginally or excessively high Delta T, so the high evaporation conditions. So we take the data from before, we can add on this condition in the West. It was the equivalent of 5 days, averaged across the 3 years, or 20% of the time where you had both marginally high wind and marginally high Delta T. In the East, it was the equivalent of 3 days in June or July, or 15% of the time, where you had the high wind and the marginally high Delta T. So as an applicator, it would make sense to have strategies in mind to counteract these elevated Delta Ts, because they do make up a considerable portion of the available time you have for spraying. A bit of good news is that one of the other next most prevalent conditions is ideal spray conditions, where you have winds that are low, gusting from 0 to 10 miles per hour, along with ideal Delta T conditions. So in the West, to add this in, it was 5.2 days, or 21% of the time in June or July, averaged across these 3 years. In the East, fairly similar, 4.5 days, 22% of the time. So you're in the West about as likely to have those ideal conditions as you are to have the really challenging conditions. In the East, over these 3 years, you are a little bit more likely to have those ideal conditions than the highly challenging wind and Delta T conditions. Another lesson learned, again, 2021 was a particularly challenging year for Delta T. Just to look at this in a little bit different way. Now these figures show the 3-year average on the left, and then just 2021 by itself on the right. So these are the 4 western locations, so average across the 4 western locations. There wasn't much of a difference in 2021 with the ideal conditions. It was actually quite similar to the 3-year average. But what the difference was is that when you had those high wind conditions, they were much less likely to be paired with in ideal delta T, and much more likely to be paired with high delta T conditions, or those challenging high evaporation conditions. So the 3-year average in the West was 5 days. It was 6.1 days in 2021. 1.5 days on average to have excessively high delta T with high wind. Well, that was more than doubled in 2021, 3.2 days with marginal high wind and excessively high delta T. So it's just challenging because not only were you dealing with high wind, but you were also more often dealing with high delta T along with that high wind. In the East, again, not much difference in 2021 with the ideal spray conditions, but those high winds were much less likely to be paired with optimum delta T, much more likely to be paired with high delta T, high evaporation conditions. Went from 3 days on average to 4.7 days in 2021. In the East, fortunately, there wasn't that much of an increase in the unsuitable delta T conditions, but still, applicators in 2021 had to deal with those marginal high delta Ts, the high evaporation conditions that can cause efficacy issues and can cause drift issues. So 2021 in the East, it was about equal between those ideal conditions and the highly challenging conditions, which was about what it was like on average in the West. So applicators in the East in 2021 had to live like applicators in the West just had to live on average across those 3 years. So to summarize, what is delta T? It is the evaporative ability of the air. So the higher the delta T, the more evaporative ability of the air. Why does it matter? It matters because if you have a high delta T, a high evaporation condition, you're losing droplet size, you're losing water volume, and that can cause greater drift. And also, when this happens, when the droplet's already deposited on the plant, it can reduce your efficacy, especially for a lot of these contact products. You can get the droplets, the deposits on the plant desiccating, drying out before the active ingredient has an opportunity to work its way into the plant, and that'll reduce your efficacy. On the flip side, if you have low delta T conditions, the concern there is that any drift you do have is going to be more potent, or any spray you do apply is going to be more potent because it'll persist longer, have enhanced uptake due to the low evaporation conditions. How do you monitor it? You have options. Your sprayer might have an onboard weather station. There's handheld meters that are available. The Endon app and websites are also great resources. How do you manage it? If you get into unsuitably high delta T, highly recommend you just suspend operations. You're going to have a difficult time getting effective control spraying in those really high delta Ts. If it's just marginally high, up your water volume, use bigger droplets as best as you can. That'll help to counteract the effects of that enhanced evaporation. And finally, what's the North Dakota context? Delta T trends low in the morning and higher in the afternoon. Marginally high wind and delta T are fairly prevalent, about 15 to 25% of the spray time in June and July, depending on the year. So have a plan for it. Have a plan for what you're going to do in those elevated delta T conditions, not just the elevated wind conditions that you might be used to managing. And finally, due to drier conditions being more common in the West, high delta Ts also seem to be more prevalent in the West. Thank you so much for your attention. If you'd like to find me online, the easiest way to do that is through my Linktree site, and the link is displayed on your screen. From there, you can find me in the different NDSU directories or on social media. And you also can access my public presentations that I have delivered throughout my time as Extension Agriculture Technology Systems Specialist. Thank you again for your attention.